Page 3. Determine the real roots, real and imaginary. So I got to type in to y equals, so I'm going to clear that one out of there and put in x to the 5th plus 5x to the 3rd. So there's no x to the 4th written in this equation, so that's going to be important when I do the synthetic division. Minus 7x squared plus 2x. So if I go zoom 6, looks like it came up close. It may have bounced in there, so we better go zoom 4 and look closer in that spot. Nope, it crossed at 0. Looks like it might have crossed at a half, and may have crossed at something. It crossed a couple times in there between 0 and 1. But I don't know what they are, but it did cross at 0. That means x must be a factor. And if I pull out the x, I get x to the 4th plus 5x to the 2nd minus 7x plus 2. And I'm not sure what that zero's in there, so let's see if we can find one of those. I can calculate the 0 between 0 and 0.6. I think it's about 0.5. Let's see if it is. It's at, it's not a nice number. So I must have made a mistake on this, because I would probably give you nice numbers on the test. Let's see. Not a nice number, and that was supposed to be a nice number. Okay, well, it's 0.4095271, and that's an approximation. The other one's not very nice either. I did not mean to do that. Well, we should be able to do synthetic division with that. Maybe I typed this in wrong. Let me check that. Y equals x to the 5th plus 5x to the 3rd minus 7x squared plus 2x. Did not mean to make that ugly like that. All right. So this might be a learning thing here for both of us. So there's 1x to the 5th, no x to the 4th, 5x to the 3rd, negative 7x squared, 2x, and 0. So if I put 1, take it times that answer, I think that's still an x. Yes, that's still an x, that whole big number. So 1 times that is going to be that number, 0.4, blah, 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 blah. Add it to 0, I'm going to get that number, 0.40952, blah, 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 blah. If I take that times itself, so x squared, that will get me 0.1677. If I add that to 5, I'm going to have that 5.1677, whatever. Then if I take it times that x, times x, I'm going to get 2.116 something, and then I got to add a negative 7. So subtract 7, and I'm going to get negative 4.88 something something something, times that x again, times x, and that's negative 2 plus 2 is 0, times that is 0, and that's 0. Okay? Now I also could use 0 in here, and that would get rid of one of the zeros. In fact, I should have taken it out. I should have just used this, which should have been just this and not that. So I have the x. Now I have x minus 0.409, ugly 0. And now I've got the other 0 in there, and we could do that one. let's see here. So go back to the graph. There's the graph, and it looks like it goes through somewhere between 0.5 and 1. So second, calculate the 0 between 0.5 and 1. And my guess is 0.8, and it says it is 0.79682 something something something. Now that's in X. So if I quit, I can go ahead and put down my 1, take it times that, and I would get the 0.79682. And I'd have to add it to that old number, which I lost now, so off they go. My new X is that plus 0.40952 is 1.2063. That times the X. And that gives me a new number, 0.9612, to add to 5.1677, and that's 6.1289 times X, and I get a positive 4.883, and that comes out 0. So these are the zeros. Determine the roots, real and or imaginary. So I've got 0 for this one. I have positive 0.409, and I have a positive 0.7967, and then the other two must be imaginary, and I'd use that for A, that for B, and that for C in the quadratic formula to get those. I can do that. Okay, let's do it. Program. Oops, not on this calculator. Quadratic formula is on this calculator. On stat. No, program. Quad form. Enter. The A would be 1. The B would be 1.2063, and the C is 6.1289, and it says they're unreal answers. So to get the imaginary ones, I'd have to go to mode and turn on A plus BI, and now program, quadratic formula, do it again, 1.2063 and 6.1289, and I get negative 0.603 plus 2.401i, and with a minus on it, plus and minus there, negative 6.603 minus 2.401i. Okay, determine the intervals where the function is negative. I apologize for this. I will try not to have decimal looking ugly things like that on the test. Okay, determine the intervals where the function is negative. So we have the graph of that function, and it's negative up to 0. So from negative infinity to 0. It's not negative 0. And between these two roots, and so that would be between 0.409 and 0.797. Those are the two places where it's negative. Alright, I got a couple calls here, so I'll take care of that, and then I'll go on.